Hey, this is the beauty and majesty of what's going to be a grip machine. Your grip machine. My son cut out the parts. Last Wednesday, I had purposely, subconsciously forgotten about a dental appointment that I had, so I didn't get to work on this as much as I wanted to Thursday. Got everything cut up, but didn't get everything going as much as I'd wanted to with that. So, anyway... well, that Wednesday, so Thursday is today, so hell with it. Get the point of it. Didn't make as much progress yesterday as I wanted to, so we're jumping in here like this. I'm going to cut this down. This is actually cut to the wrong length, but we'll wrap this up and we're going to get over there on that machine. We're going to drill some holes for the grommets that's going to go in the feet, and that's one of the changes I've made from the first version. This is actually a Generation 3 grip machine. Went through 3 iterations of making it better. So let me get, it's gonna look like magic. It's gonna cut and go over there now. All right, a bit loud, but there is the fruit of our efforts. So if you'll notice, you've got an angle on this hole, and there's different angles on bits. But oops, done got caught. But this isn't an exact match for this bit, but the angle is designed to start the hole so much better. These bigger bits, a lot of times what happens is you burn up the outside edges here because it's like swinging a kid around. If you've ever held your kid's hands, and swing them around. You're spinning really slow on the inside, but the outside, the perimeter, is spinning much, much faster. Long story short, you've always got to worry about burning the tips up. You can see this one's got a little hot there. But for this thin of stuff, it'll be okay. You can see a little color discoloration there. You've got to flood these things really well or, slow them down. But anyway, that's what we're doing here. It just helps drill center hole, not mess up hole. Good thing. Yep. I don't know where we're going to pop over to next. Probably over there. Give me a count of 1, 2, and... All right. She didn't go as planned. While I got through, of course, enough pressure and enough lubricant, you can push through about anything. Get your mind out of the gutter. All right, so she's chafed right up. What happened here? That spot I was showing you before, that's kind of what happened to it. You can look at the chips, and some of them have a little bit of a blue tinge to them. That's where the bit was getting too hot. I should have backed off of it, but I was almost through, so anyway, gonna have to resharpen her. The way we go about that is, we're gonna hold them at an angle here. You've got your flute angle, all kinds of crazy stuff to go on here. Got into this at one point, but I figured I learned it was way too complicated for me, so I just went back to the way an old timer showed me to sharpen bits and do it by eye and do it by hand, and like this better than a drill doctor. So anyway, just gonna do it and then dip it in something cool to keep it cold or keep it from getting too hot, because this takes off a lot of material at one time, and anytime you're removing a lot of material with raw horsepower and friction, it produces heat, so you have to keep this thing dipped in the liquids. All right, later. Hope you're enjoying stuff like this, because it's fun to do. All right, I've begun to dress down the tip. So if you'll notice, I'm trying to keep great or good or really nice symmetry here. The trick to this is to use this guide. You see this thing over here, and it's supposed to be designed for drilling, for doing the bits. The way I was shown that works best, you don't do that. You hold the angle here, you make a couple passes. Focus, damn you. Make a couple passes with your bit, using your finger as a guide here. You match the angle, and then you just come forward a little bit, match the angle, rotate your bit. Yeah, this should be a factory edge. Get a couple practice runs and then hit it a couple times, trying to just make sure that you're keeping what you got. And with a little bit of practice, it's really easy to keep almost machine-like some symmetry here. Now, if you'll notice here, it's the angle's a little not ideal, but I've got the point where I want it. What I'll do here is I'll dial it down. So I'll cut this other surface. Say my thumb's all the way down here, like down where my knuckle is. So that's all like too big glove. Don't ask me. I got some seconds, some factory second gloves, and they got the thumbs is just freaking crazy big. So it's got this one really long thumb, and then the fingers are normal. So anyway, it was El Cheapo gloves. They're really nice leather gloves other than that. So anytime you get stuff from like Pakistan and things like that, they're really, for a long time in boxing gloves and stuff, there was notorious about the thumbs and fingers being just, you're liable to have one, you know, the fingers of a midget and a thumb of a giant. That's kind of what we got here with this glove, but they're gloves, what can I say? All right, on to round two. Yeah, I know, you're thinking move on already. I get it. Wanted to show you this though. No, that ain't it. I'll clean all that up before it sits this way. Damn it, which one is it? Well, you see how clean that hole looks? Like the outside edges of it? Focus, damn you. All right, there you go, the outside edges of the hole, okay? Now the one where the bit was all gnarlied up, yeah, here it is. You see the results of the friction where the part where it didn't drill through cleanly. So I'll knock that off with die grinder. But that's what happens whenever that outside edge, that periphery of the circle starts getting hot, the metal gets hot, and instead of cutting it, it becomes soft and it pushes through. So, all right, I just thought you might find that interesting. Hey, we're back. All right, I don't do this a whole lot. That's why I'm using this tool. There are definitely better methods to do so, but focus, damn you. Ah, wrong thing, come on. Focus, there it is. This one's been a bit too hot. You get a 200-pound gorilla, me, pulling on the handle bit up here because he's a little over-ambitious, wants to get shit done, and you end up, this is burnt somewhat. I think it'll be good enough for this task, but definitely going to have to look in getting one of these, another one. So this can be done on metal with a hole saw. Most of them say, you know, they're rated for, they're bimetal and rated for metal or steel, or wood or steel. Anyway, the trick is consistency. So anytime that you're drilling a hole, if you can keep your drill bit perpendicular, perfectly perpendicular to what you're drilling, that's how the bit's designed to freaking drill. Seriously, it really is. If you're doing something like this, you're burning that edge up that we talked about before, and you're not getting proper penetration. So here, and you want consistency. If you've ever drilled a hole and you've got a manual drill and you're doing all of this, that's not good on the bit. That's not good about getting the hole done. One of these are like 1,000,000,000 times worse because it wants to grab, hang, pull, torque, twist. That's why this works best if you have something like a mill or a pretty solid drill press. If you look at a lot of drill presses, it's not rated over 5/8 for the hole anyway, so that can be a bit of a problem. Definitely not enough to turn one of these things. Other than that, gonna get back on this. Oh, and another reason most people can't turn these is if you look at the aggressive part of the bit here, the tooth, which that was done burnt plumb out, they're thinner, which means that it doesn't dissipate the heat as well. So it heats up quicker, easier to burn through. If you turn them at anywhere near the RPMs that you're going to turn with a hand drill, it's going to be super easy to just absolutely destroy them mega quick. So what I do is I use a variable frequency drive. So what that does is it varies the frequency or the pulse rate of electricity going to the motor and actually slows it down. This particular mill, you know, you can slow it down the manual way with the belts and the pulleys, but the variable frequency drive makes it a lot easier. There are some drawbacks. They're not, honestly, for what I'm doing, it's not that big a deal. If you were making huge chunks of chips fly, the horsepower and everything would matter more. You do lose a little horsepower, but way more than it takes to do most applications I'm doing. All right, I'm gonna drill these through. Catch you later. Next thing I see, probably gonna be over there working on the welding of the other parts. See ya. Everything will go together pretty quick from this point. We've got this tacked together. We got your base welded together here. So, focus you. Yeah, I got that welded up. So, and then whenever we put the top on it, we'll finish capping off the corners on these welds. So what that means is, if you'll notice I held back, just stopped a little before the corner. So what I'll do whenever I finish this up, I'll come down the corner and wash back up. So and come over. So it's just a thing that I do whenever I'm welding points that's gonna merge on, focus, damn you, on several axes or several points there. I'll hold back and leave a nice place so I can wash back into the first weld. Anyway, blah, 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 blah. I probably won't do any more videos on this because I don't want to show it to you too much, because of course you're going to get the finished product. But this is some of the things that goes into building your grip machine, man. This one's yours. Enjoy it. Appreciate the patience on the lead time. Getting super busy, and we're probably going to be moving the shop before long. So take care. All right, this is it. I wasn't going to show this part of it because I wanted to leave a little something for the imagination, but here we go. This is your machine. This is she's super smooth either side. A lot of the bolt together things, you've got the carriage over here, and it's bolted together and stuff. Welded together, it's one solid piece. It's not, it just stays so much smoother. You can't get that if you bolt something together. You always have to worry about, especially when you're doing heavy weight and dropping stuff, binding and warping and all that. So anyway, big striker plate down here at the bottom. So whenever you slam it down, it's good to go. Anyway, it's the last part of the video. I want to make sure that, you know, you may get the video before you get the machine. It looks like our pickup didn't come today, so I have to, you know, have to contact them and see what their pickup schedule is this week. We live out in rural Kentucky. People, private contractors and stuff, so try to cut the guys some slack. If y'all haven't noticed, get into that some other time. Whole ball of wax there. Anyway, take care, man. Looking forward to you getting this and you letting this guy know how you like it. See ya.